Hello students, so today I am going to do a topic called dimensions, which comes under the chapter units and dimensions. Okay, so let me tell you what is a dimension here. So dimensions of a physical quantity are the powers to which the fundamental physical quantities are raised to express that quantity completely. ಸೊ ಹಾಗಾದರೆ ಏನು ಡೈಮೆನ್ಷನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಇಲ್ಲಿ ನೋಡಿ, ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ 7 ಫಂಡಮೆಂಟಲ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆ್ಯಂಡ್ ಆ 7 ಫಂಡಮೆಂಟಲ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ವಿ ಕ್ಯಾನ್ ಡಿರೈವ್ ಪ್ಲೆಂಟಿ ಆಫ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್. ಸೊ ಅದನ್ನು ನಾವು ಡಿರೈವ್ಡ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಡಿರೈವ್ಡ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ನಾವು ಫಂಡಮೆಂಟಲ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಪವರ್ಸನ್ನು ರೇಸ್ ಮಾಡಿ ಡಿರೈವ್ಡ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೋದು. ಅದೇ ಡೈಮೆನ್ಷನ್ಸ್ ಆಗಿರುತ್ತೆ. ನೋಡಿ, ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ಅ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಆರ್ ದ ಪವರ್ಸ್ ಟು ವಿಚ್ ದ ಫಂಡಮೆಂಟಲ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆರ್ ರೇಸ್ಡ್ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ದಟ್ ಕ್ವಾಂಟಿಟಿ ಕಂಪ್ಲೀಟ್ಲಿ. ಯಾವುದೋ ಒಂದು ಡಿರೈವ್ಡ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿನ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, with the help of powers of a fundamental physical quantity, we are going to represent that quantity. We are going to express that quantity. Such a term is called dimensions. So nodi, for example, if I consider density. So how we are going to define density? So density can be defined as mass divided by volume. So we can define density by this ratio. Mass by volume will give you density. Right? So here this is equals to, we'll write the mass as mass itself, and volume can be defined as, it is the product of length into breadth into height, right? So volume ಅನ್ನು ನಾವು ಈ ಥರ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ಇಟ್ ಈಸ್ ಲೆಂತ್ ಇಂಟು ಬ್ರೆಡ್ತ್ ಇಂಟು ಹೈಟ್. ಸೊ ಲೆಂತನ್ನು ನಾವು ಯಾವ ಥರ ಮೆಷರ್ ಮಾಡ್ತೀವಿ ಅಂತ. ಲೆಂತ್ ಇಸ್ ಅ ಫಂಡಮೆಂಟಲ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ವಿಚ್ ಕ್ಯಾನ್ ಬಿ ಮೆಷರ್ಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಅ ಮೆಷರಿಂಗ್ ಸ್ಕೇಲ್. ಸೊ ಲೆಂತನ್ನು ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಮೀಟರ್ ಆರ್ ಸೆಂಟಿಮೀಟರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೆಷರ್ ಲೆಂತ್. ಬ್ರೆಡ್ತ್ ಅಂತ ಹೇಳಿದ್ರು ಕೂಡ ಇಟ್ ಈಸ್ ಲೆಂತ್ ಇಟ್ ಸೆಲ್ಫ್, ರೈಟ್? ಬ್ರೆಡ್ತನ್ನು ಕೂಡ ನಾವು ಸೇಮ್ ಮೆಷರಿಂಗ್ ಸ್ಕೇಲಿಂದ ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ದಟ್ ಇಂಡಿಕೇಟ್ಸ್ ಲೆಂತ್ ಇಟ್ ಸೆಲ್ಫ್. ಈವನ್ ಹೈಟ್ ಈಸ್ ಆಲ್ಸೋ ಮೆಷರ್ಡ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಸೇಮ್ ಮೆಷರಿಂಗ್ ಸ್ಕೇಲ್. ಸೊ ಹೈಟ್ ಈಸ್ ಆಲ್ಸೋ ಅ ಲೆಂತ್ ಹಿಯರ್, ರೈಟ್? ಸೊ ಇದು ಮೂರೂ ಕೂಡ ಲೆಂತೆ ಅಲ್ವಾ? ಲೆಂತ್ ಇಂಟು ಬ್ರೆಡ್ತ್ ಇಂಟು ಹೈಟ್. See, now I am going to represent this fundamental physical quantities in terms of powers. Okay, see, density is a derived physical quantity. It doesn't come under 7 fundamental physical quantities we have, right? So ee density na now mass by volume agi barkondidini. Again ಈ ಮಾಸ್ ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮನ್ನು ಲೆಂತ್ ಇಂಟು ಬ್ರೆಡ್ತ್ ಇಂಟು ಹೈಟ್ ಆಗಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ವೇರ್ ಲೆಂತ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಲೆಂತೇ ಆಗಿರುತ್ತೆ. ಬ್ರೆಡ್ತ್ ಈಸ್ ಆಲ್ಸೋ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಲೆಂತ್ ಇಟ್ ಸೆಲ್ಫ್. ಹೈಟ್ ಈಸ್ ಆಲ್ಸೋ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಲೆಂತ್, ರೈಟ್? ಸೊ ಈಗ ಈ ಮಾಸನ್ನು ನಾನು ಶಾರ್ಟ್ ಫಾರ್ಮಲ್ಲಿ ಬರೀಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ವಿಲ್ ರೈಟ್ ಮಾಸ್ ಆಸ್ ಜಸ್ಟ್ m ಡಿವೈಡೆಡ್ ಬೈ, ಆ್ಯಂಡ್ ಫಾರ್ ಲೆಂತ್ ವಿಲ್ ರೈಟ್ l into, I told you breadth can also be measured by considering this as length. So ಇದನ್ನು ಕೂಡ ನಾನು L ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಈವನ್ ಹೈಟು ಕೂಡ ಸೇಮ್ ಮೆಷರಿಂಗ್ ಸ್ಕೇಲೇ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಮೆಷರ್ ಮಾಡ್ತೀರಾ. ದಟ್ ಈಸ್ ಲೆಂತ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ L into L into L, that is nothing but what? L raised to 1, L raised to 1, L raised to 1, and here m raised to 1. This is equals to m divided by, okay, so here you have a multiplication sign. Okay, ಇದು ಮೂರು ಕೂಡ ಪ್ರಾಡಕ್ಟಲ್ಲಿದೆ. ಅದರ ಪವರ್ಸನ್ನು ನಾವು ಆ್ಯಡ್ ಮಾಡ್ಬೋದು. ಸೊ 1 + 1 + 1 is L cube. So m divided by L cube ಆಗುತ್ತೆ. So therefore the dimensions of density is represented by rho here. So I am representing this with a rho symbol. Okay, dimensions of density can be written as m raised to 1, okay, divided by L cube ಇದೆ. So if I take that L cube to the numerator, it becomes L raised to minus 3. Okay, and ಇಲ್ಲಿ ಇನ್ನೊಂದು ಟರ್ಮ್ ಅನ್ನು ನಾನು ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ, that is time, and the short form of time is just t raised to 0 ಅಂತ ಬರೀತೀನಿ. So anything to the power 0 is equals to 1. So here we have to represent the dimensions by a square bracket. So this will give you the dimensions of density: m raised to 1, L raised to minus 3, t raised to 0. Or you can simply read this as ml minus 3 t 0 or ml minus 3 ಇಷ್ಟು ಬರೆದ್ರು ಆಗುತ್ತೆ ಆಯ್ತಾ. So here ಇಲ್ಲಿ ನೋಡಿ, m is nothing but mass, short form of mass. L represents short form of length and t represents short form of time here. So m, mass, is a fundamental physical quantity, length is also a fundamental physical quantity, and time is also a fundamental physical quantity. So here we are raising the powers of fundamental physical quantity to express the derived physical quantity. So we are expressing the derived physical quantity with the help of fundamental physical quantity. Only we are raising the powers of fundamental physical quantities here. So idanna now dimensions anta karitivi. See, unit is different, dimension is different. Clear? Yesterday we were discuss about unit, physical unit, and two types of unit we have: fundamental unit as well as derived unit. But here dimensions anta helidre fundamental physical quantities na powers na raise ಮಾಡಿ ನಾವು derived physical quantities na express ಮಾಡ್ತಾ ಇದೀವಿ, represent ಮಾಡ್ತಾ ಇದೀವಿ. So this is what we call dimensions. Now you can understand the definition of dimensions, I hope. Dimensions of a physical quantity are the powers to which the fundamental physical quantities are raised to express that quantity completely. Clear? Okay, let me tell you some of the derived physical quantities where we can express the derived physical quantity with the help of fundamental physical quantities by raising their powers. Okay, so let me consider area. Area is a derived physical quantity. So area has a formula: length into breadth. Length into breadth. So nodi, dimensions can be obtained easily. Only the thing is you should remember the formula. So ನೀವು ಇಲ್ಲಿ ಫಾರ್ಮುಲಾಸ್ ನ ಬೈ ಹಾರ್ಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ, and don't put force on to remember the dimensions here. So dimensions na by heart mado necessity illa. Only the thing is you have to by heart the formula of a particular physical quantity. Clear? Area is equals to length into breadth, right? So therefore dimensions of length na baritini, that is L. Dimensions of length is L, whereas dimensions of breadth is also L. So therefore this can be written as L square, right? So this is equals to L represents L raised to 1. Again L represents L raised to 1 here. So L square, and this can be written as m raised to 0 L square t raised to 0. Okay, anything to the power 0 is equals to 1, so that I am writing m raised to 0 L square t raised to 0. So this is the dimension of area. Clear? And let me consider speed. Speed or velocity, which is a derived physical quantity. Okay, so here first I have to write the formula of speed. ಸೊ ಸ್ಪೀಡನ್ನ ಯಾವ ಥರ ಬರೀತೀರಾ? ಡಿಸ್ಟೆನ್ಸ್, ರೈಟ್. ಆ್ಯಂಡ್ ಫಾರ್ ವೆಲಾಸಿಟಿ ಇಟ್ ಈಸ್ displacement, both divided by time taken, right? So therefore this is equals to distance or displacement can be measured by considering a measuring scale, right? Distance is the length between 2 points. So distance is nothing but length. Displacement is also a length between 2 points, but it in a particular direction. So here this can be represented like this. Length in distance in L in the measure martira divided by time. Time in the new capital T in the represent martira. So therefore dimensions of speed can be written as m raised to 0 L t raised to minus 1. Okay, so this is in the denominator. If you take this, see, t raised to 1, L raised to 1. If you take this to the numerator, then it becomes minus 1. M raised to 0, L, t minus 1. Clear? Now let me consider another derived physical quantity here, that is acceleration. Acceleration. So again I have to remember the formula of acceleration. So acceleration can be written as velocity divided by time. Velocity divided by time. So just now I have found the dimensions of velocity. So I am going to write the dimensions of velocity here, that is m raised to 0 L t minus 1 divided by time. Here dimensions of time is t raised to 1. So therefore the dimensions of acceleration is m raised to 0 L t raised to, if it goes to the numerator it becomes minus 1, that is minus 2. So this will give you the dimensions of acceleration. Similarly, we'll consider another derived quantity here, that is force. So what is the formula of force? So force can be defined as the product of mass into acceleration. Product of mass and acceleration. So therefore mass, it is a fundamental physical quantity. So mass can be represented by using a symbol called capital M, and acceleration is L t minus 2. So therefore the dimensions of force is m L t minus 2, or you can read this as m raised to 1 L raised to 1 t raised to minus 2, or you can simply read this as mlt minus 2. So this is the dimensions of force. Similarly, we'll consider work as my derived physical quantity. So first I have to write the formula of work to find the dimensions of work here. So work can be defined as force into distance. Force into distance. Clear? Force into distance. So what is the dimensions of force? First I have to write the dimensions of force. Again I have to write the dimensions of distance here. So dimension of force is, just I have got the dimension of force here, that is m L t minus 2, mlt minus 2 into distance. Distance can be measured by considering that as length, right? So therefore what is the dimensions of work here? Work is nothing but m L into L, L square t minus 2. So these are the dimensions of work. Okay, so here I have written 5 derived physical quantities and their dimensions. Area having a dimension L square. No need to remember the dimensions, only you have to by heart the formulas. Okay, if you know the formula, then you can easily find the dimensions of that particular physical quantity. So here this is a derived physical quantity. Area can be defined as length into breadth. So length can be considered as length, which can be represented by L. Breadth is also considered as length, so it can also be represented with the help of the same term. So therefore it becomes L square, so which can be represented like this: m raised to 0 L square t raised to 0. Anything to the power 0 is equals to 1. So I'm writing like this. Again, speed and velocity. So you should remember the formula of speed and velocity. If they ask you to find the dimensions of speed, first you have to write distance divided by time. First you have to write the formula of speed. So LT minus 1. And velocity kedidre displacement divided by time, you'll get the same dimension. So dimensions of speed and velocity are same, that is LT minus 1, or you can read that as m raised to 0 LT minus 1. Clear? And here I have written acceleration. Acceleration is equals to velocity divided by time. So ಇಲ್ಲಿ ನಿಮಗೆ velocity dimension ಗೊತ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ again you have to go here. So velocity ಅಂತ ಹೇಳಿದ್ರೆ displacement divided by time, ಅಲ್ಲಿಂದ ನನಗೆ LT minus 1 ಸಿಗುತ್ತೆ, and divided by t ಹಾಕಿದ್ರೆ you will get LT minus 1 divided by t, that is m raised to 0 LT minus 2. Okay, so force ಅಂತ ಹೇಳಿದ್ರೆ ಏನು? Mass into acceleration. So mass having a dimension m, acceleration is having a dimension LT minus 2. So finally you will get the dimensions of force here, that is mLT minus 2. So once you know the dimensions of force, you can easily find the dimensions of work here. So work dimensions yav tara calculate madabodu anta helidre by knowing the formula of work. So work is equals to force into distance. So this is equals to, I know the dimensions of force, so we'll write the dimensions of force here into distance. Dimensions of distance is L. So finally we'll get the dimensions of work here, that is ml square t minus 2. Clear? Hope you understand this. Let me consider some more derived physical quantities here, and we'll tell you how we'll get the dimensions, how we are going to write the dimensions of that physical quantity. So work, right? And now let me consider energy. Energy is nothing but amount of work done. ಸೊ ವರ್ಕ್ ಮಾಡಿದ್ರೆ ತಾನೆ ಎನರ್ಜಿ ಎಷ್ಟು ಯುಟಿಲೈಸ್ ಆಗಿದೆ, ಎನರ್ಜಿ ಎಷ್ಟು ಸ್ಪೆಂಡ್ ಆಗಿದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಹಿಯರ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್. ಸೊ ಎನರ್ಜಿ ಆ್ಯಂಡ್ ವರ್ಕ್ ಹ್ಯಾವ್ ದ ಸೇಮ್ ಡೈಮೆನ್ಷನ್. ಸೊ ವಿಲ್ ರೈಟ್ ದ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ energy as ml square t minus 2. Just now we have done here. So I got the dimensions of work, but energy is nothing but amount of work done agirodrinda we'll get the same dimensions for energy also. Clear? Okay, let me consider another derived physical quantity here, that is pressure. So pressure can be defined as force divided by area. Okay, so here I have to write the dimensions of force, what I have done before. So dimensions of force is m l t minus 2 divided by area can be defined as length into breadth. So here dimensions of area is L square. So therefore m l t minus 2, and we'll take this denominator to the numerator, so it becomes L raised to minus 2. So therefore minus 2 plus 1, becomes L raised to minus 1. So the dimensions of power would be m L raised to minus 1 T raised to minus 2. So these are the dimensions of pressure. Okay. Similarly, let me consider another physical quantity here, that is impulse. Impulse of a force or impulsive force or impulse anta kareevi. So let me write impulsive force. So how we are going to define impulsive force and what is the formula of impulsive force anta helidre. So impulsive force is having a formula force into time. Okay, impulsive or impulse, force into time. So this can be represented with the dimensions. So force is having a dimension mlt minus 2 and time is having t. So therefore impulsive force or impulse can be written as m l t. Okay, so this is minus 2 and here you are having plus 1. Minus 2 plus 1 is minus 1. So m l t minus 1 is the dimension of impulsive force. Suppose if I want to find the dimensions of gravitational constant. See, first we'll write the formula of the gravitational constant. Okay, so you know F is equals to G m1 m2 divided by r square, where F represents the force, G represents the gravitational constant, m1 represents the mass and m2 represents the mass of second particle and r represents the distance between those two particles, right? So this implies G is equals to, if I do the cross multiplication we'll get the value of G. So therefore fr square divided by m1 m2. Now I can easily find the dimensions of G here because I know the dimensions of force. I know r is the distance, m1 is the mass, m2 is also the mass. So therefore the dimensions of gravitational constant can be written as, first we'll write the dimensions of force, that is mlt minus 2, and the dimensions of r, that is nothing but distance, r square. So you have to write L square here divided by mass m, another mass we have, that is m. So we'll write the final dimensions of gravitational constant here, that is C m L into L square, that is L cube into t minus 2 divided by m square, right? So therefore if I take this m square to the numerator, it becomes m raised to minus 2. So we'll write it here only. Hope you won't have any difficulty in understanding this. M L cube t minus 2 m minus 2. So this is equals to m raised to minus 1, right? Minus 2 plus 1 is minus 1. M raised to minus 1 L cube t raised to minus 2. So these are the dimensions of gravitational constant G. Okay, so here we'll write G as gravitational constant. Clear? Similarly, let me consider another physical quantity here, that is power. So power can be defined as the ratio of work by time. So this is the formula to find power, that is work divided by time. So therefore, what is the dimension of work here? We have already know the dimensions of work. So work has a dimension ml square t minus 2 divided by time. So therefore, this is equals to ml square t raised to minus 2, and here you are having t raised to 1. So if it goes to the numerator, it becomes t raised to minus 1. So therefore, t raised to minus 1, t raised to minus 3 is, minus 2 becomes t raised to minus 3. So this is the dimension of power. Okay. So ಈ dimensions ನಿಮಗೆ ಇಲ್ಲಿ ನೋಡಿದಾಗ first time you are watching how we can calculate the dimensions of a derived physical quantity. ಇದು ನೋಡಿದ್ರೆ ನಿಮಗೆ ತುಂಬ ಡಿಫಿಕಲ್ಟ್ ಇದೆ ಅಂತ ಅನಿಸ್ಬೋದು, but it is not difficult. It is very easy to do. Okay, so only the thing is you should by heart the formulas of a particular physical quantity. If you know the formula, then you can easily write the dimensions of any physical quantity. Clear? Okay, so let me consider another physical quantity that is stress here. So stress can also be defined as force by area. Okay, so this is the formula for stress, force by area. So therefore, first I have to write the dimensions of force, then I have to write the dimensions of area here. So what is the dimension of area? What is the dimensional formula for force? So force having a dimensional formula mlt minus 2 divided by dimensions of area is L square. So the final dimensions of stress is M. If it goes to the numerator, it becomes L raised to minus 2. So here already you are having one L in the numerator and you are having L square in the denominator. I am taking this L square to the numerator, so it becomes L raised to minus 2, t raised to minus 2. So final dimensions of stress is M. L raised to 1, L raised to minus 2 is L raised to minus 1. Minus 2 plus 1 is minus 1. So L raised to minus 1, t raised to minus 2. So this is the dimensions of stress. Similarly, we have one more derived physical quantity here. So why I am telling these physical quantities? Because in first year you are having all these terms. ನಾನು ಏನೇನು ಹೇಳ್ತಾ ಇದ್ದೀನೋ ಎಲ್ಲದೂ ಕೂಡ ನಿಮಗೆ ಈ ಇಡೀ ಫಸ್ಟ್ ಇಯರಲ್ಲಿ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಫೈನಲಿ you'll get to know what is stress, power ಅಂತ ಹೇಳಿದ್ರೆ ಏನು, strain ಅಂತ ಹೇಳಿದ್ರೆ ಏನು, gravitational constant ಅಂದ್ರೆ ಏನು. Okay, so let me consider strain here. Strain ಅನ್ನು ನಾವು ಯಾವ ಥರ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, so it can be defined as change in length divided by original length. Change in length divided by original length. So this is how we are going to define strain. Okay, so ಈಗ change in length ಏನಾಗ್ತದೆ, ಚೇಂಜ್ ಆಗ್ತದೆ. So which can be measured with the help of a measuring scale or measuring instrument. ಲೆಂತನ್ನು ನಾವು ಯಾವ ಮೆಜರಿಂಗ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟಿಂದ ಮೆಷರ್ ಮಾಡ್ತೀವೋ ಸೊ ಅದನ್ನೇ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಲೆಂತನ್ನು ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಹ್ಯಾವಿಂಗ್ ದ ಡೈಮೆನ್ಷನ್ ಎಲ್, ಒರಿಜಿನಲ್ ಲೆಂತ್ ಅಗೇನ್ ಹ್ಯಾವ್ ದ ಸೇಮ್ ಡೈಮೆನ್ಷನ್ ಎಲ್. Right, L raised to 1, L raised to 1. So it becomes L raised to 1 minus 1, right? If it goes to the numerator, it becomes minus 1. So L raised to 1 minus 1, that is L raised to 0. Anything to the power 0 is